All right, now we'll talk about negative angle identities, which can also be called odd and even identities. All right, so when thinking about the unit circle, we've talked about before how we can use the acronym All Students Take Calculus, All Students Take Calculus, to describe the positive and negative trig functions in each quadrant. So thinking of a negative angle, what we need to derive here is the sine of a negative theta, cosine of negative theta, tangent of negative theta. And after we figure out those, we can find out those other three reciprocal. So we can think about cosecant negative theta, secant of negative theta, and cotan. All right, so all students take calculus. So up there in the first quadrant, I know that all of my trig values are positive. So that means sine is positive, positive, cosine is positive, and tangent is positive. Okay. So if we're thinking about theta, if I had a theta value, which is just an angle that comes up, remember it comes up from the positive x-axis, and a positive angle is going to rotate up. So maybe a different color. So there's theta there rotating up. But if I think about negative theta, so negative theta is going to rotate clockwise. So this would be negative theta. Negative theta would rotate in this direction. Okay, and in that quadrant, that fourth quadrant there, only cosine is positive. So our trig values would be a negative sine theta. We would have a positive cosine of theta. And then we'd have a positive tangent. Oops, excuse me, negative. Okay, so thinking about, we can fill in our chart now. So sine of negative theta is going to be a negative sine of theta. Cosine of negative theta is positive cosine theta. So we don't need to write positive. Tangent of theta is negative tangent of theta. Right? And we can describe these as being odd or even. So sine is an odd function, cosine is an even function, and tangent is odd. We'll learn more about that next year. All right, so then we can also figure out our reciprocal identities because they behave just the same as the others. So cosecant behaves like sine, so it's going to be a negative cosecant of theta. And I'm using parentheses. It's because the negative's out there. I need to. All right, so secant is of negative theta is secant of theta, and cotangent of negative theta is negative cotangent of theta. All right, so let's use these identities to simplify an expression. So we'll have example 5 here. And in this example, we're actually going to simplify an expression. So that the difference between simplifying and proving or verifying is that it's just an expression. It's not an equation. There's no equal sign. But what we're going to try to simplify it to is one single trig expression. So I need to simplify it to be just one single sign, cosine, tangent, cotangent, cosecant, or secant. And the expression we need to simplify is cotangent of negative theta over cosecant of theta. Okay, so I'm going to still make my toolbox over here of my identities that are helpful that I'm going to use. All right, so we're going to have to use all of the things we've learned so far to simplify this into one single thing, one single trig expression. So I'm going to start with the numerator, cotangent of negative theta. I can rewrite this using my identity there, that cotangent of negative theta is equal to negative cotangent of theta. So negative cotangent of theta over r cosecant of theta. I won't write my parentheses. Okay. All right, now what do we do? Because we need this to be one single expression. Well, I know that, so I've got a fraction here. I'm gonna split it up. So I'm gonna split this into negative cotangent of theta times 1 over cosecant of theta. Because from here, I'm gonna be, it's gonna be more safe to work with our fractions that we swap out with our different identities. All right, so I know cotangent is sine over cosine. So I'm going to add that to my list over here. Cotangent of theta is sine, oops, excuse me, cos over sine. Cosine of theta over sine of theta. All right, so I'm going to swap that out. So negative cosine theta over sine of theta times 1 over cosecant theta. Well, 1 over cosecant of theta is the same as sine of theta. So sine theta is 1 over cosecant theta. Because remember, I want this to be one thing, one expression. It's not really a thing. So I still have negative cosine of theta over sine of theta times, now instead of 1 over cosecant, I'm going to rewrite this as sine of theta over 1. Okay, now I think we're good to go. So I see I have, I can multiply by numerators now. So I have negative cosine theta times sine of theta over sine of theta over 1. I mean, times 1, which is, I don't need to list that. All right, so now my sines divide out. So sine divided by sine is just 1, leaving me with negative cosine theta. Now, I'm not checking because I didn't verify anything. However, you could use verifying strategies to work your way back. All right, now try one on your own.